Hello friends, welcome back to the video. Due to my laptop problem, couldn't make a video for a week. I am Amoga. What's up? What's going on? If you are visiting this channel for the first time, do press the subscribe and bell button in order to get an regular updates. This channel provides the information about C programming with an tricky questions of it, programming the Cortex device both in assembly and in C languages, basics of machine learning with an introduction of an deep learning, and few definitions of an science and technology. If you are interested with these kinds of stuff, please do subscribe. So in the last video you have been seen about how to configure an assembly level languages on a device LPC2148. So today's agenda of talking on a video is, first one is what is machine learning, what is different which is going to make in a machine learning compared to a traditional one. First agenda is, let's make out what is machine learning. Machine learning is like teaching to an kid. In the similar fashion, the computer is also need to be taught by making use of an millions of data. Mark my words here, millions of my datas. So the data set will be in a matrix format. It can be an video, audio, or an images. It can be anything. So data set means we won't train them in a whole image or an whole audio or an video formats. Only an features are going to be get collected and we are going to prepare a data set. If the application is face identification, you can collect some top 20 eigenvalues for an each images or an each person, and you can just prepare an data sets. If it is an audio, you can collect an MFCC data and prepare an data sets. If it is an video, then no problem, you can apply the same algorithm what you have been applied for an images, but you need to convert video into an frames. For each frames you need to apply the same algorithm which you have been applied for an images. So in a machine learning we are having an three phases. First one is training phase, second one is an validation, and third one is an testing phases. So before making the system to understand, we are going to divide the data set into an training, validation, and an testing phase. So the percentage of division of an data is left to an user, but in a standard format 60% of an your data set have been reserved for an training, 20 have been reserved for an validation and an testing. So for an understanding sake, let's consider we are having an 10,000 images. So in 10,000, for a training set we have been reserving an 60% of it, mean to say 10,000 of 60%, it is giving 6,000 images for training set. So for an validation 20% of an 10,000, that is 2,000, and for an testing as well the 2,000 images have been reserved. For understanding sake, I am showing about the how the data is going to be get splitted into an testing, training, validation. Go check this image and come back. So this is an validation of an test and an data, which is in an MATLAB neural network toolbox. So here you can see that for an training they have been sampled for an 70%. So rest 30% have been reserved for validation and testing. So this is have been shown in a MATLAB toolbox. So next, what is training? As we told before, 60% of an data sets images have been reserved for an training. It is the phase in which computers start understanding or analyzing the real world through numbers. The most important thing in this phase is we have an features of an images and a label for that respective image. So the label says that to which class the respective image have been belonged to. See, consider if your class is human being, so the features of human being will be listed in a right side and the label will be provided saying that it is a human being. General phase of an training has been shown in this figure. Just make a look on this respective figures. So this is the general structure for training any of the machines. The very first stage is collect the data, choose the features, choose the model, and choose the training model, train and classify it, training and classifier, and last one is evaluation of and classification. So let us see in this step by step. So the very first step is collection of and data. Here we are going to collect an good data. Here good means easily separable data. Easily separable means you can divide the data easily between two classes. Second step is choosing and features, which plays a very important role. You need to choose. You are going to provide a major discretable features between class 1 and then class 2. So next one is choosing a model. It can be a classifiers, it can be a neural networks, or it can be a deep learning methodologies or an architectures. So based on your applications, you can choose any of these models. So the next one is training and model. So try different approaches and check the error rates by making use of several kinds of an architectures. So next one is train the classifiers. So based on the features obtained, make and decisions. So it has been left to an machines. Machine is going to understand, analyze the features, and it is going to provide some results. So later, last stage is our evaluation phase, whether the trained machine is working fine or not. So find the least square error. If it is satisfactory, just leave it off. If the results is not satisfactory, just change the data. So you need to see about data, later data representation, what features you are extracting from an data. So number of an data, you can just increase the number of an data, or else you can just change the classifiers. So these are the possible solutions after having an evaluation. So that was about the general phases of an training. By the end of an training phase, there will be a division between two classes as shown in this figure. Just check out this figure. This figure have been downloaded from an internet. In this figure you can just see in two classes. One have been represented by an stars, another have been represented by an circles. So you can just consider it as a positive class, and this one is a negative classes. So in order to make a difference between a negative and a positive classes, you need to have one of an hyperplane. So in those several lines, how to select the best hyperplane which is going to differentiate between two classes? Do comment on this. What is validation? As told before, 20% of an dataset images have been reserved for an validation. Many times we often hear that validation data is not seen. It actually means that the label of those features will be not provided to an machines for those 20% of an images. So label means to which class that the respective image have been belong to. So the classes can be an human being, vehicles, plants, and lots more. At the end of an validation, machine is going to provide an accuracy. So based on this accuracy, the human can just change the hyperplane which have been generated in a training phases. So you can see what are all the methods to change this hyperplanes in a next video. So the last one is, what is testing? I told you before, only 20% of an data set have been reserved for a testing phase. So here both the data points and an labels are unknown to our machines. So hence the performance is going to be get determined accurately here. So whereas in validation we are going to have an features without label. In a training we are having both labels and an features, but in a testing we are not having anything. The machine should understand, analyze, and it is going to provide a decision. So fine, I'm providing one of an suggestion for an machine learning beginners is that if the accuracy rate of an training and an testing is very much varying, if it is 60% and the testing is of 40% or an 30%, that case is called as an overfitting. If the accuracy rate of an training and an testing are marginally same, then the procedure is acceptable. So in the next video we shall discuss about what is underfitting or overfitting and what are the reasons for this underfitting and overfitting and how to overcome them. So that's it for this video. Remember to subscribe. Stay tuned to get an tech related videos. If you find this video is helpful to your friends, do share them. Give thumbs up for this video. Thank you for watching. Meet you all in the next videos. Thank you.